So in order for us to be able to move on and you guys to be able to do some of the next section, we're going to talk now about maximum and minimum and finding the maximum or minimum of a function, or finding the value of a variable that will make a function a maximum or a minimum. Okay, so if we have a function f of x, or maybe I'll just use a different letter for a change, c of z. So I have a function c that depends on a variable z. So if c of z is z cubed minus 2z squared plus 6z minus 8, okay, c might be the cost of something, and z might be the number of items that you're making. So your cost, or your profit it might be, depends on the number of items you make. So if you want to figure out what's the maximum value of c that I can have, then you would differentiate the function with respect to the variable. So you'll get 3z squared minus 4z plus 6. And we know from previous work that when you differentiate, you find dy by dx, which is the slope of the tangent. And we know that when something is a maximum or a minimum, when a function at a maximum point of a function, we know that dy by dx is 0. And it is also 0 at a minimum point of a function. So if we differentiate and put it equal to 0, we will then find a value of z that makes this function a maximum. Now in this situation we're going to get two answers for z, and I made this up so I'm not going to solve this quadratic. Let's say z is 3 and z is 2. How do we know which of these is the maximum or the minimum? It might not be a nice straightforward function, so you might not just be able to put it in and see, obviously. So if you remember, what you do is you differentiate a second time, you find d2y dx squared, so you'll get 6z minus 4 in this case. Then you will put your 3 in, and you will put your 2 in. And whichever of these answers gives you the minus, okay, in this situation actually they both will, so if I'm maybe put in minus 1 in here for z, they're your two answers. So when you put 3 in here, you're going to get 18 take away 4, which is plus. That means that the point where z is 3 is going to give you your minimum. Remember, when d2y dx squared is positive, that is your minimum. And when d2y dx squared is negative, that will give you your maximum for those two values of z in this case. Actually, in this situation, it's not going to be it'll be d2c dz squared, d2c dz squared, because in this situation our function is called c and the variable that it depends on is z. Okay, so similarly here that should be dc by dz, and that should be d2c by dz squared. Okay, alright, so I'm going to do the examples in the book, and that should help for you to and allow you to be able to do the next exercise. Okay, so the first example, a factory produces n items in 1 hour, or n items per hour. The overhead costs is a function c, and the overhead cost depends on n. And the way that it depends on n is c of n is equal to, in euros, 400. So obviously it's the cost in euros. I'm going to just leave out the euros. 400 minus 16n plus n squared over 4. Okay? And the question is, how many items, what value of n? In other words, how many items should be produced to keep the overhead to a minimum? So we want to know what value of n will make this a minimum. Now, just looking at it anyway, it's a plus n squared graph. Okay, so it should be a U shape. So we know, actually in this situation, we're only going to get a minimum when we put dy by dx equal to 0. Or not necessarily dy by dx, in this case it's dc by dn. So we're going to differentiate this and get dc by dn, We're differentiating this function with respect to this variable. dc by dn is minus 16 plus, bring your 2 down, so it's 2n squared, 2n rather, over 4, so minus 16 plus n over 2. Now, to find where that's a maximum or a minimum, in this case it will be a minimum, we will put dc by dn equal to 0 and find the value of n that makes it 0. Okay, so let's multiply across by 2. Minus 32 plus n is equal to 0. N is equal to 32. What's that telling us? It's telling us that the overhead, the minimum overhead you will get it when n is 32. So if you make 32 items per hour, that's when your overheads will be a minimum. And if you want to know what your actual overhead will be, you can put the n into that function and it will tell you. Didn't ask you the question. Okay, the next one. These are the examples that are in the book. Okay, the next one. A closed rectangular box. Its length is 3 times its width. Its width is known as x, so I'm just going to call this x. So its length is 3 times its width, and its volume is 36 centimeters squared. Cubed. Okay, so we want to, what is the question? Show that the surface area is, so get an expression for the surface area, and then find the dimensions of the box with the least surface area. So first of all, we want the surface area. So the surface area is going to be a front and a back, the surface area of those two, left and right, the surface area of those two, and top and bottom. Okay, so for the front and the back is 3x by h. So here's h here, okay. They didn't call it anything in particular here. Nope. Okay, 3x by h. And we're going to need to multiply that by 2 because there's a front and a back. Okay. Now, the left and the right is going to be x by h. X by h. So x by h, and then we multiply that by 2 because there's a left and a right. Okay. X by h. And the top and the bottom are x by 3x. So x by 3x, and again there's 2 of them. It is a closed, it's a closed box. Always check if it's closed or open. So that is our surface area. Okay, so let's add it up. We have 6xh plus 2xh plus 6x squared. Okay, so 6x squared plus 8xh. Now, we have a problem because we've got a h in the answer. So we need to remember we have an extra piece of information. The volume is 36 centimeters cubed, but we know the volume of this box is 3x length by width by height. So we know that 3x by x by h equals 36. That's 3x squared h is equal to 36. Divide by 3, x squared h is equal to 12. H is equal to 12 divided by x squared. Okay. Now, we can put that in here for h. So the surface area of the box is 6x squared plus 8 by x by 12 over x squared. Okay, so that is 6x squared plus x, one of the x's, well, 96, that'll give you 96x over x squared, and divide top and bottom by x, so plus 96 over x. S surface area is equal to, you can put it as 6 if you want, you can factor out times x squared plus 16 over x. I'm not sure what way they want it. Okay. Yeah. figured out the surface area, they want us to find the dimensions of the box with the least surface area. Now what you do have to be careful with here, I don't know if it's the case in this example, you do have to be careful that you are using realistic values as well for x in the context of the question. Okay, so we have the surface area is 6x squared plus 96, and instead of writing over x, I'm just going to put it as x to the power minus 1, because in order to find the value of x that makes the surface area a maximum, we will need to differentiate the surface area with respect to x. So dSA by dx is equal to 12x minus, we're going to bring 96, well, plus 96 times minus x to the power minus 2. That's 12x minus 96 x to the power minus 2, which is 12x minus 96 times 1 over x squared, or 96 over x squared. Now, to find what makes the surface area a minimum, we need to put our dSA by dx equal to 0 and figure out what the value of x is. Let's multiply across by x squared, so we're going to get 12x cubed minus 96 is equal to 0. Divide by 12, x cubed minus 8 equals 0. Now the interesting thing here is that is an x cubed, so it's a plus x cubed graph. Okay, so let's just look at that in the context of the question. So it's a plus x cubed graph. So we know a plus x cubed graph looks like that. So again, technically it's a cubic graph, it should have 3 roots. Okay, we would normally find the roots by factorizing, and you have x cubed minus 2 cubed equals 0. How do we factorize a cubed minus b cubed? It's x minus 2 times x minus y times x squared plus xy plus y squared. Oops. Okay, that's the factors. So we want to put that equal to 0, so we can see straight away one of our answers is when x is equal to 2. X minus 2 equals 0, x equals 2. The other answers would be the solution to this quadratic, but when you factorize this, you will find that you only get imaginary roots. So there is only one real answer to x cubed minus 8 equals 0, and that is x equals 2. So from that we can see that x is 2. I know some of you are tempted now to say x cubed equals 8, just bring the minus 8 over and then get the cube root of both sides, which is perfectly okay, except that you are losing sight that there are actually 2 other answers. In the context of this question they don't matter because they're imaginary, but just to be aware that x cubed minus 8 equals 0 has 3 roots, 2 of which are imaginary. Okay, so x is 2. So we now know that the value of x being 2 is what's going to give you your, now, is it your minimum or your maximum surface area? And I mean, again, technically, to make sure that it is your maximum surface area, or minimum surface area, you should differentiate a second time. So what do we get if we differentiate a second time? This was what we got when we differentiated the first time. So what do you get if you differentiate 12x minus 96 over x squared? If that was d surface area by dx, then d2 surface area by dx is equal to 12 minus, now that's 96x to the power minus 2. So you're going to get 12 minus plus now, because you're going to bring the minus 2 down and multiply, 192 x to the power minus 3. Okay, and when we put our value of plus 2 in here, we get a plus answer. Remember the plus 2 from here? So we know that that value gives us a minimum. Okay, now obviously it's the only value, so you kind of know it's the minimum, But again, technically it's good maths to show that it is the minimum by showing that d2sa by dx is positive. So that is the value of x that makes the surface area minimum, and I think they actually asked you to find the minimum surface area, so you now need to go back and put x equal to 2 in here. And what did we say h was? H was 12. I think h was 12 over x. I can't honestly remember for sure. So h is 12 over 2, which is 6. If I'm right, I don't have the book with me. I just have it online and I can't use it with my laptop open. Okay, so 3 by 2 is 6, so the dimensions should be 6 by 2 by 6. 6 is 36, by 2 is 72. Oh, it's the surface area they want. Sorry, I'm giving you the minimum, or I'm giving you the volume. It's the surface area they want, so you actually need to put x equal to 2 back into the expression for the surface area. And I don't have the expression for the surface area, but you need to remember to do that. Okay, the expression for the surface area is in the book. Okay. I'm going to do the third question separately because it'll take a little bit longer and you really need to watch the third question.